Alright, so today's lesson, we're still going to look at slope from a graph. We're going to look at slope in similar triangles. And you have your reference material. You can look at it. At the very top, it says linear equations. And then the third item right below, it says slope of a line. Okay, we are going to be using that formula today with graphs. We're also going to use it on Tuesday with tables and 2 points. Okay, and so today's lesson, by the end of the lesson, your goal is to answer questions that look like this. So problems like this that you'll see we have a graph line with triangles, and we looked at triangles on graphs yesterday. And then looking at this, and then also with numbers. And this is using the formula that I just showed you on your reference material. Okay, so this is our goal. Okay? All right, so we're going to use the graph to answer the questions below about Joe and Kelly's work. Okay, so in order to find the slope of the graph shown, Joe chose the points 0, 0, and 2, 4 to make a right triangle. Okay, so we're going to draw this triangle graph at the rights. So let's go ahead and graph 0, 0 on that point, and 2, 4. And we're going to make a right triangle. And we always do our rise and then our run. So we should have that right there. All right, and we're going to go ahead and write that formula. So looking at your reference material, to find slope of a line, we're going to use this formula. You do need 2 points to use this formula. So we've marked our 2 points here. Okay? So we have M. And what does M represent? If you're trying to find slope, M represents slope. Why did they not choose the S? I'm not sure. But M always represents slope. Are we good? So we have on your reference material y2 minus y1 over x2 minus x1. All right, so those subscript numbers, all that is labeling the second y, your first y, this is your second x value, and your first x value. That's all that means. Okay, are we good with that? Okay, so we have our 2 ordered pairs right here, 0, 0, and 2, 4. So 0, 0 is our first set of ordered pairs, right? So there's always an x value and a y value. And so this is our first set of points. So this is our first x and our first y. That's all that means. Are we good so far? And then we have our second set of points, 2, 4. So this is our second x and our second y value. Are we good? Okay, so instead of doing rise over run, you have this option right here to use this formula to determine slope of a line. Okay, so now let's just substitute our numbers in. What is our second y value?
4.
Good. 4 minus, what is our first y value?
0.
Good. Okay, so that's our change in y, right? We learned that yesterday. Our change in y over our change in our x. So notice we are finding change, which is why we are subtracting. Okay? And then what is our second x value?
2.
Good. And we're going to subtract our first x value, which is 0. 4 minus 0 is 2 minus 0 is 2. And just like yesterday, we're going to simplify if necessary, and we get 4 divided by 2 is 2. So M equals 2. Okay, let's go ahead and look at our graph. What type of line is that? It is a positive, and we did get a positive 2. Are we good with that? All right. Okay, so we were supposed to do that here. All right, so using Joe's triangle, what is the slope of the graph? And Okay, so now we know that Kelly chose 2 points. She also chose 2, 4. We've already graphed 2, 4 here. And 5, 10. So let's go ahead and graph 5 up 10. Let's go ahead and draw this right triangle. So just learning from what we did yesterday, if you choose any points on a line to determine the slope, should we get the same slope?
Yes.
Should Kelly have the same slope?
Yes.
Absolutely. Okay, and this is what it's showing again as well. Okay, so to find the slope, we did that. We are going to use our formula. Let's go ahead and we always start off with the formula. And it is M, which represents what? Slope. Good. And then we have y2 minus y1, your change in y, over your change in x, x2 minus x1. Okay, it's also good to also label the ordered pairs. And our first set of ordered pairs that were given to us is 2, 4. So this is our first x value and our first y value. And then 5, 10 is our second set of points. So this is our second x value and our second y value. Now we're ready to substitute in our numbers. Make sure that we're here. So our second y value is 10 minus 4 over the change in x, and our second x value is 5 minus 2. 10 minus 4 is 5 minus 2. Simplify, and that gives us, good. How are Joe and Kelly's triangle related? Okay, they have the same slope. How are they related? Are they similar? Yeah. The triangles are similar.
The triangles have the exact
Because the sides are proportional. So let's go ahead and create a proportion using this and that. Are we good? Okay, and I want to show you, remember our end goal was to try to, that's where that comes from right there. So they use that formula to set up and show that the triangles are proportional using the points. And so you've already done that, right? And then so we have, what's his name? Joe. So we have 4 minus 0. Let's go ahead and write that right there. 2 minus 0, right, is proportional to Kelly's triangle, which is 10 minus 4 over 5 minus 2. The triangles are similar because their sides are proportional, and this represents their sides. Okay, how do we know that? Okay, this is Joe's triangle, this is Kelly's triangle. Okay, what is the rise? 4 units, right? And our run is
2 units.
2 units. Look right here. Did you see that? Okay, and then let's look at Kelly's. Kelly's rise is 1, 2, 3, 4, 5, 6, and her run is 1, 2, 3 units. And look right here. Pretty good. You see your rise over your run right there? See how it all kind of relates? It's so cool. Okay, so the sides are proportional, right? Are we good so far? All right. So I want you, you're also going to see something like this with sides that are proportional. So we're going to go ahead and label Joe and Kelly's triangles with letters. And we're going to create proportional sides with the letters. So if this is triangle A, B, C. That's Joe. And then Kelly's gonna have her triangle, and hers is gonna start with C, D, E. You good so far? All right. Now, if we're gonna make a proportion using this formula, we always want to do our rise over our run, right? So we can use what we learned yesterday. We're going to write it just right here, okay? So let's focus on Joe's triangle, okay? And what is our, using the letters, let's do our rise over our run. So what side is our rise for Joe? What is our rise? A, B, good. And what's our run? You got it, B, C. And that's proportional, so A, B is gonna, so this rise has to correspond to rise, right? Rise and rise, so what is Kelly's rise?
C.
You got it, C, D. And her run is D, E. Good. Not that bad, right? So you can see it with letters, you can see it with numbers, using rise over run and your slope formula. Why can you use any 2 points on a line to find the slope of the line? Why? The slope of a line is constant, right? Does it ever change the slope? No. So the slope of a line. It's constant because we saw parts of the line. We got the same slope, right? All right, now based on what you know, which of the following triangles will also lie on the line graphed above? What was the slope of the line graphed above? Slope equal, what did it equal? It equals 2, okay? So with your table, I want you to try number 7. All right, so each of these triangles, they've already provided your change in Y and your change in X, right? So for A, you could use what we used yesterday, our rise over run, right? So our change was, and Y was our rise was 26. Absolutely. Can I finish talking? All right, thank you. All right, and our change in our X value was 14, and that simplified to 13/7. Are we good with that? Does this match? No. So, not A. Do you want to help with B? Yeah. Okay, go for it.
So what I did is if you look at the graph and you count the distance between 4 and 4, look at the bottom one.
Right here, Joe.
Yeah, you see it has a 2 and 4.
Yes, sir.
Technically, it also corresponds with B's numbers, which is basically that if it's whatever number is the X value, the Y value is going to be twice that, which corresponds with B perfectly.
Absolutely. Exactly what you said. You're correct.
I know because I used my calculator.
Good. And I like how you explained that too. So 36 divided by 18 does give you a slope of 2. And then, what about C? We have 30 over 12, our rise and our run, and that gave us 5 halves. Okay? So it looks like only triangle B, right? All right? Turn over to the next page, and I want you to do 8, 9, 10, and 11. Okay, oh, and if you could for number 11, do you see how your triangles right here, What is that? What is their slope?
Negative.
It should be negative, so if you could just put in a negative right here, that would be great. And I want you to be careful with number 9 when you're determining that slope. Okay? Pay attention to what type. Okay? Make sure you always check that. Alright, you're going to draw 2 different sized triangles that could be used to find the slope on the graph below and label the rise and the run. And you're going to explain the relationship between the triangles. Okay? So the 2 triangles that I did, first I got to pick my points, right? Here and here. I'm going to draw my right triangle. Okay, I can also choose this one. And my triangle could go from here to here, but I actually want to do one from here to here. Okay, and look at your y-axis with the intervals. They go by what? They go by 2. Somebody knows that. All right, so let's draw the 2 different sized triangles that can be used to find the slope on the graph below and label the rise and the run. So we have our first set of points, which is 0, 0. And that can be your x1, y1, and our second point is, did I say 34? All right. And we are going to use so our second y value is 4 minus 0 and 3 minus 0, right? We're doing that. But you get 4/3. Good. Okay, and if we do the second one, I'll change colors here. We can use 0, 0. As our first set of points, and our second set of points, so let's say 6, 8. Okay, and we can substitute that in our second y. And that simplifies to what? 4/3. Are we good with that? Okay, explain the relationship between the triangles. They are what? They're similar triangles, right? So this goes back to similar figures. So when we're looking at similar figures and triangles, they're going to have what? Same slope. Isn't that cool? All right. Clarify anything? All right, number 9. Which of the following triangles also lie on the line graph below? All right, so we have we're going down for our rise, right? So we're going down 30 and 55, right? We're going down 28, 45, and we're going down 26 and 39. And triangle A simplified to -6/11. And what about triangle B? Not this one. Which I'll get. 4, 5. Awesome. So which of the following triangles would also lie on the graph line? So we need to determine the graph line, right? So let's choose our 2 points. 0, 18, x1, y1, and let's choose this one right here, and that is 3, 16. We're good? And so we're going to do change in our y value over the change in our x value. And our second y value is 16 minus 18. And then we have 3 minus 0. What's 16 minus 18?
-3.
Good. -2. 3 minus 0 is 3. So we're looking for a slope that's negative 2/3, and that is triangle C. Are we good? Yeah. Are y'all practicing using this at all?
Yeah.
Okay, good. Okay. Rise over run. I think y'all like a lot better, right? Because y'all did down 2 and then 3. That's fine too, but then you'll see stuff like that too, so please be familiar with that. Number 10, circle the triangle that would not lie on the same line as the others. Okay, so we are going up 28, or change, they already provided, and that equals what? 4, 68, and the change in our x is 17, and that gives us 4 as well, right? Yeah, and then we have a change in 77 on our y, and our change in x is 19, and that is already simplified, right? It's not 4. All right. Did you do that? Okay, did anybody attempt number 11? So answers are going to be a little different. What'd you get?
I did,
Huh?
for one of them, I did 2 for the rise, or, yeah, 2 for the rise, or negative 2 for the rise.
Okay, but we're not going to put negative 2. I know on your paper it has negative numbers, but like a distance on a triangle really can't be negative. So you just need to know, like when you look, that it's going to end up being negative. Okay?
And then the run is 10.
Good. Oh my God, that's what I had. Okay, so your 2/10 simplifies to 1/5, and we see that our slope is going down. I like that. And then what'd you do for the other one? Did you do the other one?
Oh, yeah,
What'd you do?
I did 3 and 15.
Good. Okay, do you see how they are proportional? Similar figures are proportional. So you have 2/10 equals 3/15, right? I think I actually did, and you can keep going, right? 4, if you had a side of 4, it would be 20. You just keep going. Very good? Yeah, they're all proportional. They're all similar figures. All right, so I'm going to give you this, and I'm going to have you, I'm going to give you about 5 minutes to answer both of them, and then we'll see how you did. Okay?